Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Apollo 14, Uncovering the Secrets of the Moon. In 1971, humans returned to the moon, but this time, they brought more than just science, they brought a bit of humor with them. Yep, the moon wasn't just about leaving footprints anymore. Apollo 14 not only brought back lunar rocks, but also a golf club. The Apollo program, launched in 1961, had one simple goal: get humans to the moon. And Apollo 11 achieved that in 1969 with the iconic words, "That's one small step for man, one giant leap for mankind." Of course, footprints were left on the moon. But Apollo 14? It did something different. Apollo 11 got us there. Apollo 14 made us believe you could not only collect rocks on the moon, but you could also play a round of golf. Apollo 14 wasn't just about fun and games, though. Apollo 11 had given everyone confidence, and missions like Apollo 12 and 13 followed suit. But Apollo 14? That mission was the real MVP of the Apollo relay. Not only was it the third moon landing, but it pushed space science forward. The astronauts didn't just collect lunar soil and study moon rocks, they also brought back some serious scientific equipment. But here's the kicker: the most famous part of Apollo 14 wasn't the science, it was the moon golf. Enter Alan Shepard, the first astronaut to ever swing a golf club on the moon. Picture this: in the moon's low gravity, Shepard could hit a golf ball farther than anyone could ever dream of on Earth. Remember, he almost didn't even make it into astronaut training because of health issues. But what did he do? He went on to space and took golf and humor along for the ride. So, Apollo 14 didn't just provide humanity with a ton of scientific data. It also gave us a funny story that proves life on the moon, apparently, has its lighter moments. The Apollo program, starting in 1961, was like America's space race fever. The goal? Send humans to the moon and see what they could do once they got there. The mission was clear, but the challenges were immense. Finally, in 1969, Apollo 11 took that giant leap with Neil Armstrong's famous words, "That's one small step for man, one giant leap for mankind." But things didn't go quite as smoothly after that. Take Apollo 13, for example. That mission was almost so close, yet so far disaster. The astronauts on Apollo 13 encountered a fatal technical failure, nearly ending the mission. Did they give up? Nope. Their survival story could be its own blockbuster film. They didn't quite finish the mission, but they sure made it home safe. Sometimes, space exploration is all about threading the needle, right? Then came Apollo 14, the third moon landing, and the pressure was on. It not only had to make up for Apollo 13's almost done, but also had to continue the scientific work that Apollo 11 and 12 had started. Apollo 14 wasn't just about getting to the moon and snapping a few photos, it had bigger fish to fry. The astronauts needed to gather moon rock samples, conduct experiments, collect data, and continue expanding humanity's knowledge of the moon. And this wasn't an easy job. I mean, picture this: the moon doesn't have much of an atmosphere. Every single move had to be calculated with surgical precision. Yet, somehow, Alan Shepard still found time to play golf on the moon. Yes, you heard that right, he swung a golf club and hit the first ever moon golf ball. In the moon's low-gravity course, the ball flew farther than any earthbound golf ball ever could. At this point, who wouldn't crack a smile? So, Apollo 14 wasn't just about stepping on the moon, it opened new doors for scientific research and brought back a bunch of major discoveries. And the most important takeaway? Well, it brought back a golf record that'll be tough to beat here on Earth. In 1961, Alan Shepard, the man who would go on to be the first to swing a golf club on the moon, stepped onto the stage of history. At just 32 years old, Shepard had already become one of NASA's Mercury astronauts. Back then, he had no idea that in just a few years, he would become the first American to fly in space. And he certainly didn't expect that his name would forever be linked with the moon, cementing him as part of a legendary moment in history. Shepard's childhood wasn't exactly ordinary. Growing up in Massachusetts, he was surrounded by the sounds of planes, as his father was a Navy officer. From a young age, Shepard dreamed of becoming a pilot. That dream was nurtured throughout his life. By 1950, he had joined the U.S. Navy as a pilot, and during a flight, his performance caught the attention of his superiors. Shepard was a skilled flyer, but he wasn't perfect. There was that one time his dad scolded him for a small mistake during training, which made Shepard realize that perfection didn't happen overnight. Instead of getting discouraged, he became even more determined. By 1959, Shepard passed NASA's rigorous selection process and joined the Mercury program. On May 5, 1961, Alan Shepard became the second American to travel into space. Though his flight lasted only 15 minutes, those 15 minutes laid the groundwork for NASA's future giant leaps. But what really etched Shepard's name in history? It was his incredible achievement in 1971 when he became the first person to play golf on the Moon. Alongside his colleague Edgar Mitchell, Shepard embarked on an unprecedented adventure. They conducted scientific experiments, collected moon rocks, and, yes, Shepard hit some historic golf balls. That moment, imagine hitting a golf ball on the Moon, is still a source of laughter and wonder today. Let's talk about Edgar Mitchell, who had his own fascinating story. Growing up in Florida, Mitchell was always curious about the universe. While in high school, he briefly thought about becoming a scientist, but soon, his focus shifted to the Air Force and aviation. Mitchell's flight career started off strong, and his exceptional flying skills got him selected for the U.S. Air Force. However, he wasn't the social type and often preferred solitude, thinking deeply while in the cockpit. Eventually, Mitchell joined the Apollo program and became the lunar module pilot for Apollo 14. His mission wasn't just to collect moon rocks, but also to complete complex scientific experiments. But Mitchell wasn't just a calm scientist, he also had a surprising interest in the supernatural. In 1971, while on a flight, he experienced a strange spiritual encounter, which led him to delve deeper into the study of human consciousness and psychic phenomena. This alien experience made Mitchell one of the most unique astronauts. As for Stuart Roosa, he may not have been in the spotlight as often as Shepard and Mitchell, but his importance was undeniable. As the command module pilot for Apollo 14, Roosa was responsible for maintaining communication with Earth and ensuring the coordination between the lunar module and the command module. He didn't step foot on the Moon, but his role was crucial to the success of the mission. Roosa had an extraordinary aptitude for science and engineering from a young age. Born on the West Coast, he developed a fascination with electronics and mechanics. By high school, he was already fixing the family TV and radio. His parents joked that he was smarter than they were. After joining NASA, Roosa's tasks weren't as visible, but he was always the steady hand behind the scenes, ensuring everything ran smoothly. He worked closely with Shepard and Mitchell, ensuring their operations were precise. Apollo 14's mission was no easy feat, it was the third moon landing. If Apollo 11 was humanity's first step, Apollo 14 was like the grand opening of the Moon. After Apollo 11, the Moon was like a luxurious hotel that everyone was eager to check into. Apollo 14 was the team that really opened the door and said, "Come on in." Thanks to the success of Apollo 11, the Moon wasn't an unknown anymore, but Apollo 14 took it to the next level, transforming the Moon from a place of iconic footprints to a scientific treasure trove. On February 5, 1971, Apollo 14 successfully landed. Shepard and Mitchell boarded the lunar module, nicknamed Antares, and prepared for their moonwalk. The landing site was chosen in the Fromaro region, which had a relatively flat surface ideal for exploration. Back at Mission Control, the tension was palpable. This wasn't just a casual moon stroll, it was an intricate scientific expedition. After much training and calculations, the astronauts successfully landed. Compared to Apollo 11, Apollo 14 was more like a professional moon exploration. Apollo 11 showed us that we could leave footprints on the Moon, but Apollo 14 revealed what secrets the Moon was hiding. Shepard and Mitchell's moonwalk wasn't just about taking a few steps and snapping pictures. The lack of atmosphere on the Moon meant that every move had to be calculated with precision. Clad in bulky spacesuits, their movements were slow and deliberate. They weren't just walking, they were working. Shepard and Mitchell were like moon janitors, tasked with collecting rock and soil samples, setting up scientific instruments, and getting the most out of their time on the lunar surface. Forget brooms and trash cans, they had the most advanced space equipment. They carefully used their tools to collect rock samples, ensuring each one was correctly labeled and stored. And those moon rocks? They didn't just look cool, they became valuable treasures back on Earth, providing scientists with crucial insights into the moon's origins and geological history. In fact, Apollo 14's mission was all about unlocking the moon's mysteries, how it formed, its geological layers, and its relationship with Earth. To do that, Shepard and Mitchell had to patiently sample and conduct numerous experiments. They brought back moon rocks and soil samples that helped scientists better understand the moon's geological evolution. Can you imagine? These small rocks held millions of years of lunar history, each one like the moon's ID card, telling stories of the past and future. So, Apollo 14 didn't just land on the moon, it opened new frontiers for human knowledge, transforming the moon into a goldmine of scientific discovery, and, thanks to Shepard, it left us with a golf record that'll be tough to beat. When Apollo 14 astronauts collected rock and soil samples from the moon, it wasn't just about bringing back cool souvenirs. Those 42 kilograms of lunar samples hold millions, even billions, of years of the moon's history. And even today, they continue to offer scientists invaluable insights into the moon, Earth, and the early history of the entire solar system. The rock collection mission of Apollo 14 is nothing short of a milestone in scientific history. Every sample Shepard and Mitchell gathered was another step in unraveling the mysteries of the moon. Compared to Apollo 11 and 12, which focused more on first steps in surface exploration, Apollo 14's mission was all about deeper scientific investigation. While Apollo 11's main focus was leaving human footprints on the lunar surface, Apollo 14's task was to dig deeper, literally and figuratively, into the moon's geology, collecting samples from various layers of lunar soil and rock. For 33 hours, Shepard and Mitchell conducted their lunar activities, and most of that time was spent collecting these priceless samples. Using specially designed shovels, hammers, and bags, they carefully gathered rocks and soil from the moon's surface. Some came from the relatively young Central Mare region, rich in fresh lunar rock, while others were from much older geological layers, crucial for understanding the moon's history. Each rock was meticulously labeled and placed into special containers to avoid contamination. Once they returned to Earth, these samples were analyzed for decades, providing scientists with a treasure trove of lunar geological data. For example, scientists discovered that the moon's rock composition is similar to Earth's, suggesting they share a common origin. These rocks also revealed signs of ancient volcanic activity and offered clues about how the moon's surface was shaped billions of years ago. Who would have thought that these seemingly ordinary rocks would hold such profound cosmic secrets? Not only do these samples help scientists understand the structure of the moon, but they also suggest the moon may have once had water, an incredible discovery that has major implications for future lunar and Mars exploration. Each sample collected by Apollo 14 astronauts brought humanity one step closer to unraveling the mysteries of the universe, and these discoveries continue to form the foundation of space exploration to this day. But Apollo 14 wasn't just about digging for lunar treasure. Shepard and Mitchell performed a series of groundbreaking scientific experiments too. One of the most famous experiments was conducted in the moon's low-gravity environment. Imagine this: they conducted the classic hammer and feather experiment, where Shepard dropped both a hammer and a feather at the same time. On Earth, the feather would fall slower because of air resistance, but on the moon, with no atmosphere, they fell at the same rate. This experiment confirmed Newton's laws of gravity and provided a direct demonstration that, in the absence of air resistance, all objects fall at the same speed. This experiment didn't just advance our scientific knowledge, it deepened our understanding of the moon's low-gravity environment. Shepard and Mitchell also conducted other physical experiments, such as using a laser reflector to measure the distance between the Earth and the moon. And here's the kicker: that laser reflector is still being used today, providing astronomers with highly accurate data about the Earth-Moon distance, far surpassing the accuracy of earlier measurements. In addition to physical experiments, Apollo 14 was packed with astronomical research. Shepard and Mitchell installed various instruments on the Moon's surface, including reflectors and detectors, which provided Earth-based scientists with valuable data. These seemingly simple tasks were actually key to later space research. For instance, the laser reflector allowed astronomers to measure changes in the Moon's orbit, offering vital insights into the gravitational relationship between Earth and the Moon. But if you thought Apollo 14's moonwalk was just about collecting samples and doing experiments, think again. It wasn't just a mission, it was more like a lunar science carnival. Shepard and Mitchell were like space scientists on a cosmic adventure, performing experiments ranging from physics to astronomy, collecting rock samples, and analyzing data. Picture this: it wasn't just a moon vacation, it was a science feast, showcasing humanity's ability to use the moon as a unique platform for pioneering experiments. And all those experiments didn't just give scientists data, they laid the groundwork for future lunar missions. Apollo 14, especially with its rock collection and physical experiments, pushed the boundaries of what we knew about the moon and gave future space missions the tools and lessons they needed to keep exploring. Now, let's not forget the iconic moment when Alan Shepard became the first person to play golf on the moon. While this little golfing escapade didn't exactly start the Lunar Olympics, it went down as one of the most memorable moments in space history. Shepard swung a modified golf club and hit a few balls, and because of the moon's low gravity, the balls flew farther than they would on Earth. Shepard even joked, "I don't want to hit it too far, or we might never find the ball." It was like a space version of golf and have fun. That moment completely changed how we imagine space missions. Shepard's lunar golf stunt didn't just make us laugh, it added a touch of humanity to the otherwise serious business of space exploration. Imagine a golf ball flying on the moon, shattering the sterile, scientific image of lunar exploration. It wasn't just about cold experiments, it was about humor and warmth. Shepard made the moon feel a little less distant, a little more like a place that could have its own fun time. This moment showcased Shepard's humor and how, even in the face of the overwhelming challenges of space exploration, astronauts could still keep things lighthearted. Even on the desolate moon, Shepard's wit added a bit of personality to the mission, making it richer and more colorful. After spending 33 hours on the moon, Shepard and Mitchell were ready to board the lunar module Antares and return to orbit. But launching from the moon was no simple feat. Even though the moon's gravity is only 1/6 that of Earth's, there were still technical challenges, particularly with the engine ignition and precise takeoff maneuvers. The small engine on the lunar module fired, gently lifting them off the moon's surface. Thanks to the lack of atmosphere, the process went smoothly, but it was still tense for the astronauts. One of the biggest challenges was making sure they were on the right trajectory after takeoff. Shepard and Mitchell had to carefully adjust their course to ensure a perfect rendezvous with the command module orbiting the moon. Once they were airborne, the lunar module began its approach to dock with the command module. This was a crucial step. The lunar module was now leaving its lunar orbit to meet up with the command module. Stuart Roosa, the command module pilot, had been waiting for them in orbit. His job was to help guide the docking process. As the lunar module closed in on the command module, Shepard and Mitchell used precise controls to ensure a smooth connection. While the moon's low gravity made the operation easier, it still required intricate orbital calculations. The docking was accomplished with a device called a capture ring, which allowed the two modules to connect without any collisions. After docking, Shepard and Mitchell entered the command module, and they were ready to leave the moon behind. But here's an interesting fact: unlike other Apollo missions, Apollo 14 didn't orbit the moon before returning to Earth. Instead, once the lunar module and command module docked, they immediately began the return journey to Earth. After completing their rendezvous, it was straight home. No detours. The mission was a success, and the data they brought back would continue to shape the future of lunar exploration for years to come. The Apollo 14 mission didn't end when the astronauts left the moon's orbit. After completing their lunar tasks, the crew Shepard, Mitchell, and Roosa knew that the most challenging part of the mission was still ahead: re-entering Earth's atmosphere. The distance between the moon and Earth is about 384,000 kilometers, and when the spacecraft re-enters Earth's atmosphere, it's going at a breakneck speed, nearly 40,000 kilometers per hour. At such speeds, the astronauts would experience extreme temperature fluctuations for a few seconds. The surface of the command module would heat up to a staggering 3,000 degrees Celsius upon entering Earth's atmosphere. That's hot enough to burn up most spacecraft, but thanks to Apollo's heat shield, the capsule survived this fiery baptism. As the command module descended, it transitioned from high-speed flight into aerodynamic braking, using the atmosphere to slow down. This was where the automatic flight system and manual controls played a crucial role. The astronauts had to carefully manage the spacecraft's orientation to ensure they landed in the designated ocean zone. After 45 minutes of intense flight, Apollo 14's command module successfully broke through the atmosphere and entered its final descent phase. The splashdown zone was about 800 kilometers from the Hawaiian Islands, in the Pacific Ocean. The Navy had already positioned recovery ships around the landing area, ready for the astronauts' arrival. The module's parachutes deployed perfectly, and it made a successful landing in the Pacific. But the descent wasn't without its little hiccups. According to Shepard and Mitchell, the command module drifted slightly during the landing, causing a small rocking motion after splashdown. Luckily, the parachute system worked flawlessly, and the Navy's recovery team was ready. The astronauts were quickly transferred to a recovery ship. Despite the minor wobble, the mission ended successfully. The safe return of Shepard, Mitchell, and Russo marked the triumphant conclusion of the Apollo 14 mission. The success of Apollo 14 wasn't just about a smooth lunar landing. It was about the priceless scientific data it brought back, especially the lunar rocks and soil samples. These samples have been pivotal in advancing science, particularly in fields like geology, astronomy, and physics. For starters, the lunar rocks and soil samples provided critical clues about the Moon's formation. These samples helped scientists study the similarities and differences between the Moon and Earth. Previously, it was thought that the Moon might have been part of Earth, blasted off during a cosmic collision. But the analysis of these rocks revealed that the Moon's history is far more complex than originally thought. These samples confirmed that the Moon is about 4.55 billion years old, matching the age of Earth and the Solar System, and supporting the theory that the Moon and Earth share a common origin. Scientists also discovered evidence of ancient volcanic activity on the Moon, which gave us a clearer understanding of its formation. Apollo 14's samples also provided fresh perspectives on the Moon's geological composition. Most prior knowledge about the Moon's surface came from telescope observations and remote sensing. These new samples allowed scientists to directly study the Moon's rock composition, revealing that the surface is primarily made up of basalt rock rich in iron and magnesium, which is common on the Moon. This finding helped us understand the Moon's geological structure and its evolutionary history. Another key discovery was the presence of helium-3 in the lunar samples. This isotope is rare on Earth but relatively abundant on the Moon. The discovery of helium-3 sparked interest in future lunar resource exploitation. Scientists believe helium-3 could be a potential clean energy source for nuclear fusion. As fusion technology continues to develop, helium-3 could become a key ingredient for sustainable energy. In the field of astronomy, these lunar samples also offered a treasure trove of data. By analyzing tiny particles and chemical compositions in the Moon's soil, scientists not only studied the Moon's age and evolution but also learned how the solar wind affects the Moon. With no atmosphere to shield it, the Moon became a natural laboratory for studying solar wind, cosmic radiation, and climate changes on its surface. The research of these samples helped astronomers better understand the properties of the solar wind and how it interacts with other celestial bodies. This will be essential for studying other planets and their environmental and climate changes. In physics, Apollo 14's experiments brought significant progress. Shepard and Mitchell conducted several physical experiments on the Moon, including the famous hammer and feather experiment. This simple test verified Newton's law of gravity and provided a new opportunity to study physical phenomena in a low-gravity environment. These experiments proved that the laws of physics still apply in low-gravity environments like the Moon, but under extreme conditions, phenomena may appear differently. This research not only had a profound impact on physics but also provided crucial data for future human space missions. The success of Apollo 14 was not just about exploring the moon, it opened new scientific doors in fields ranging from lunar geology to solar system formation, from future energy development to space exploration physics. The mission's rock samples continue to be invaluable resources for scientists, helping us better understand the moon and providing a solid foundation for future space exploration and technological advancements. And, of course, we can't forget Alan Shepard's famous moongolf moment. While it didn't spark any intergalactic sports events, it remains one of the most iconic moments in space history. Shepard took a modified golf club to the moon and hit a few balls. Thanks to the moon's low gravity, the balls flew farther than they would on Earth. Shepard joked, "I don't want to hit it too far, or we might never find the ball." That moment gave us a new, lighter side to space missions. It wasn't just about high-tech equipment and intense science, it was about having fun, even on the moon. This unexpected bit of humor brought warmth to the cold, scientific world of lunar exploration. Shepard's playful moment made the moon feel more approachable, more human, like it had its own time for fun. His humor, even in the desolate vastness of space, made the Apollo 14 mission more colorful and memorable. After spending 33 hours on the moon, Shepard and Mitchell boarded the lunar module Antares for the return journey to orbit. But the takeoff wasn't simple. Even with the moon's gravity only 1/6 of Earth's, the ascent presented technical challenges, especially with engine ignition and precise maneuvers. The lunar module's small engine fired, gently lifting the crew off the moon's surface. With no atmosphere, the process went smoothly, but it was still tense for the astronauts. One of the biggest challenges was adjusting their trajectory to ensure they would rendezvous with the command module orbiting the moon. Once airborne, the lunar module began its approach to the command module. This step was crucial. The lunar module had to leave its lunar orbit and dock with the command module. Stuart Roosa, the command module pilot, had been waiting in orbit. His job was to guide the docking process. As the lunar module closed in, Shepard and Mitchell used precise controls to ensure a smooth connection. While the moon's low gravity made the operation easier, it still required intricate orbital calculations. The docking was accomplished using a capture ring, which allowed the two modules to connect without any collisions. After docking, Shepard and Mitchell entered the command module, ready to leave the moon behind. And here's something cool: unlike other Apollo missions, Apollo 14 didn't orbit the moon before heading home. Once the lunar module and command module docked, they began their direct journey back to Earth. No detours, just a straightforward return. The mission was a success, and the data they brought back would help shape the future of lunar exploration for years to come. The people who changed the world. Usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.